So we recapped, we drew the dotted line for the graph, and we shaded everything above. Now that it's shaded above, we look at the next part, and the next part says, actually, you were only supposed to shade when x was bigger than 0. Another review from grade 10. What kind of line was an x equals 0 line? Was it vertical one, or was that the horizontal one? It was the vertical one. So x equals 0, and I've got it in red there. I'm going to draw it with a dotted line here in red. This would be x equals 0. And if I shaded everything when x is bigger than 0, okay, and I'm going to start with, it's going to be messy. Maybe you don't shade yet, but we'll make it clean in the end. But if I take out a red crayon and shade everything bigger, that would be all of this. Can you see that so far the overlapping part, I took out this little section. And now it's only these two parts that are overlapping. We need it to be shaded where everything is true. And the last thing they have, which I'll do in green, y has to be greater than 0. Y equals 0 is this line. And if I shaded above that, and again, I wouldn't do this in your notes yet, okay? Because if we shade each of them separately, it gets really messy. We have the red shaded to the right, the green shaded above, the blue shaded above the blue line. If we take away our shading, except for light blue, it's light enough. And I just add that green line back in. Can you see the place where all three of those are true? Would only be in that section. So if you shaded all three, you're looking for where are all three shaded in the end. It's only going to be in that section. Sometimes what people do in questions like this to see the answer is they, I don't know if it's called unshading or opposite shading, not really, there's probably not a word, but if you always shade the wrong part, does it make sense that whatever in the end isn't colored in is going to be your answer? So it's sometimes a nicer way of doing it. In fact, on the graphing calculator, that's often what I would do. If I had a whole bunch of lines and I was shading, I would shade the wrong way, and then I would see the part that was clean in the end. Is sometimes easier than seeing the part that overlapped with all of them. But I just wanted to show you question 13 because it was a little bit different because they added just these X's and Y's. So now it's only a section. And the reason for that is sometimes when you're dealing with a real life problem with inequalities, you can't have negative stuff. Like a person needs to buy something. They're buying chocolate bars and chips. Well, you're not going to have, oh, I bought -3 chocolate bars as part of my solution. It just doesn't make sense. So we often have these restrictions that things have to be positive in order to make sense. Which leads us into our last example. Lots of words, but some realistic stuff. Oh, look at that. Everybody loves English. You see lots of words, can't we? Carmen has $15 in her wallet. Vegetable seeds cost $1.50. Flower seeds cost $2. Write an inequality to represent the total cost of the seeds. Now we can use any letters we want. Sometimes students are partial to x's and y's because they're used to y equals mx plus b. Sometimes they like to use letters that go with what we're doing. So if you want to say, let b equal the number of vegetable seeds and f equal the number of flower seeds, can you give me an example of what she could buy? She could buy nothing. Keep her $15 and save it for chocolate bars. Yes, that is a possibility, right? But if she's really wanting to plant a garden and is excited about spring, who couldn't be excited about spring? Then what could she buy? One of each, and she'd have money left over. What do you think the most she could buy? She wants to spend all her money. Can you give me an example where she spends all her money, or is it impossible to spend all her money? 10 vegetable seeds? Yeah, just go veggies. That'll be $15 per. How do we write this as an inequality? Well, every time she buys a vegetable seed, it costs her $1.50. And every time she buys flower seeds, it costs her $2. And this has to be less than or equal to $15. She can't spend more than $15 that she has in her wallet. So you're right in seeing that if she had 10 of these and 0 of these, that makes exactly 15. Is it possible to buy flowers and spend all her money? Yes? What would be an example of that? How many vegetables? 10 vegetables? So she didn't buy any flowers then. I want to buy some flowers.
Two. She could get two vegetables.
2 vegetables? Okay, that's $3.
Six.
And then 6 flowers.
Wait, that's no.
Two of these?
Yeah, that's $6.
That's, no, 2 of these would be $3. 2 times 1.5.
Okay, 4 of that.
4 of those would be $6.
Yeah.
Okay.
4 of that, that's $6.
You have $9 left. Oh,
Okay.
can't spend all your money.
Okay, then
2 of these would be $3, and 6 of these.
Yeah.
Yes, that would work. You could get flowers and still spend some. Hey, why is it sometimes nice? Like you could have chosen this as your X and this as your Y. It might make it easier for you to rearrange things because it's more familiar. Okay, but it's not wrong to use F's and V's. You just have to figure out which is your F axis, which is your X axis. So we already solved B. What do we have? 2 vegetables and 6 flowers. Or you could buy 10 vegetables. Perfect. You can't spend all your money and just buy flowers. Unless you bargain. Right? Maybe you go up and say, if I buy 8 flowers, would you do it for $15? But then that ruins our question completely. So, can she buy 5 packets of vegetable seeds and 4 packets of flower seeds? No. How much does that come to? $15.50? I think she could probably negotiate that. Probably convince them to do that. How close can she get to $15 but still get change? You think you could get to $14.50? I think so. See if you can come up with a way to come up with $14.50. Now, if we were going to graph this one, I'm going to make this vegetables, this flowers. We said we could get 10. That's a possibility, right? If another one that we found was 2 vegetables and 6 flowers, so 1, 2, 1, 2, 3, 4, 5, 6, that would be another one that fills it up completely. But in a question like this, we can't necessarily draw a straight line. We'll be tempted to, but we can't draw a straight line because you can't buy half a package of vegetable seeds. They get very mad. It's like, that's too much. Well, I just ripped this one in half, I'll take this. Try that at a store. Oh, I don't have enough money, I'll just take half the chocolate bar. Yeah, don't try that. Although I'm sure it would be a nice hidden camera kind of thing to see the reaction of the worker.
I found how to get 1450.
How do you get 1450?
You buy 3 packets of vegetables or 5 packets of flowers.
Beautiful. So in a question like this, these are the possibilities. Any of these dots in here, in whole numbers, as long as they're, and all of these ones would work. Your graph would look like a bunch of dots in the end, just where the whole numbers work. So they have to be the elements of the integers. Questions to circle on this one? 11 and